So I don't like my last example. Let's get more sophisticated. Take a peek at how, if I want to prove, using my rigorous definition of the limit, that this is a true statement, then with my scratch work, I need to find a delta value that works. So, given epsilon greater than 0, we need to find a positive delta such that in absolute values, my f of x minus my L is less than epsilon whenever the absolute value of x minus a is less than delta. But again, we just don't care if x is equal to a. Now, massaging, just like in my last example, so just like in my last example, dividing both sides by this coefficient, I get this. And this is mathematically a grave sin for two reasons. Number one, that's not a number because I don't know what x is. Number two, if x is negative 5/3, it's undefined. So unlike my last example, I failed to come up with an upper bound for this. So I will come back. I will put in the details. And I'm afraid I need to take a break. So, note. If we can find a constant c such that in absolute values, 3x plus 5 is bounded above by it, then we will have the following. So if I can find a constant c that's an upper bound for this, then certainly dividing both sides by it, that'll give me an upper bound for this. So we will have that this is bounded above by this. So let's find such a c. To do this, I need to start somewhere. So let me just make a value up out of thin air for delta. To do this, let's choose a reasonable value for delta. Say delta is equal to 1. Now, if you do not like my choice for delta, don't worry about it. You could choose delta to be anything you don't please. If it's not small enough, don't worry about it. What I'm going to do next is going to compensate for it. Now that I'm looking at what I have here, If you don't mind, I'm not going to change it. I'm just going to change its color in blue. So here I go. Starting point. Assumption. Choice of delta. I want this. I don't have it. Absolute values are difficult to deal with. So let me get rid of them. This implies x minus 2 is between here and here. Massaging, adding 2 to all 3 sections of my double inequality. Multiplying all 3 sections by 3. Adding 5 to all 3 sections. Look at what this really says. This says this number right here on a number line is between 8 and 14. If this number on a number line is between 8 and 14, that necessarily implies that its distance from the origin is no more than 14 units. I just found my C, so I think I'll choose my delta to be equal to epsilon over my C. Now, I do think I have a serious problem. In blue, I suppose that delta is equal to 1, and in blue, I found delta is equal to this. So which one do I choose? I don't know. I think at the end, depending on what epsilon is, I'll choose whichever is the smallest. Here's my scratch work. With all I have here, I have proven nothing. Let me now let me now prove that delta should be the minimum of those 2 values. Given that epsilon is greater than 0, we will choose delta to be the smallest of these 2 values. So here I go. If this is true, then if I can show you the reader that the absolute value difference between my f of x and my L, which is I think 11, if I can show you the reader that this is less than epsilon, then I've proven that the limit of a quadratic expression is indeed equal to 11. So here I go. There is the biggest word you can find in mathematics. I made an assumption that this is true. So I will act on my assumption. This is less than delta. But this is less than 14. Now, I'm in a bit of trouble at this point. I don't know what delta is. It's the smallest of these 2 values. So here I go. If 1 is smaller than this, then delta is equal to 1. But if delta is equal to 1, which is smaller than this, then delta is strictly less than epsilon over 14. But I could be wrong. Maybe that's smaller than 1, in which case delta is exactly equal to this, which means this is exactly equal to this. And I don't know which one is true. But if this is less than that or equal to the same darn thing, then it simply means this product is less than or equal to that product, which is equal to epsilon, and I've proven what I want to show. Now that I've bridged that gap, I will make my proclamation. Now, I think that's the level of complexity at which I expect you to be